for 15 years, been present in electric vehicles. And we specialize in actually hub motors, so in-wheel electric motors. It's a little bit different than what you've seen in Trigo compared, because those are more or less hub motors developed for electric scooters that come from China. We focus on, let's say, automotive grade, higher performance, higher quality type things. And I'm going to tell you a little bit of the story behind this. So to give you an idea how we see the future and why we see the future like this, it's more or less has to do with the fact that we take a lot of inspiration from nature, from physics, from the evolution that has already happened, because we think it's the best way to learn about which things make sense in the longer run. We're interested in the long game. And when you take a look at how muscles work in a body or at animals that can be very efficient, you take a look that the muscles are very close to where you need them. It's not one big central muscle that is pulling all the strings around to make things move. And I think that the same goes for a vehicle, which means that you can have the best effect and the best efficiency if you generate the necessary power to move the car exactly where you need the force to be applied to move it. So that's within the tire. And this is how we see the future. And obviously this brings a lot of benefits, but it also brings some drawbacks, one of which my previous presenter has already exposed, and we will get to that a little bit later. When it comes to Elafe, as I mentioned, we've been doing this for 15 years, more or less. The technology is not new. It was already applied to electric vehicles about 120 years ago by even Porsche. But it took a lot of time to be able to handle all the physical limitations and all the necessary performance limitations of both the battery side and as well as the motor side. So today we are one of the leading companies that deal with high performance in-wheel motors. We also do a lot of other things among such as validation and testing and custom development of motors. But this is our specialty. And how we do it is it's based on our own patents, and we can actually make the motors as light as possible and as powerful as possible. So our specific torque that we are generating, for example, is above 100 Newton meters per kilogram of active weight, and about, let's say, 50 Newton meters per kilo of motor. So essentially, a motor for Trigo would probably be under 15 kilos or even under 10 kilos if you wanted to have 4 motors, but you could also use 2. Let me continue on. Now, I would like to explain a little bit more about why we think this is a good idea. If you take a look at how the car is complex in terms of internal combustion engines, and you see how it simplifies when you go into electric drives. And if you imagine going into a hub wheel drive, it simplifies even further. So what you essentially have is a real skateboard. And with a real skateboard come a lot of benefits that range everywhere from the way the vehicles are actually made, designed. So they can look a lot different than they need to now, and still do a lot of, and actually most and more of the capabilities of the existing vehicles. And at the same time, you can have a smaller external footprint and then a larger internal space for the user. So I think the greatest impacts come from the user experience and the safety that's connected to this. But it also has let's say, a circumstantial benefit that if you design the vehicle right, you can actually reduce the cost of the vehicle by a large factor. And even though you have to use more motors, the vehicle can actually be produced cheaper. And I think that this is the thing that's mostly important for the automotive industry. Whereas I think that where we are going with the technology is more important for the people. In the end, it's always better if everyone would ride bicycles, but unfortunately, not everyone wants to ride a bicycle. And as you said, cities are for people, not for cars. So we strongly support this because hub motors can make vehicles externally smaller, lighter, more efficient, and at the same time offer the same or greater benefit in terms of comfort and everything else. Before I touch base on the actual benefits and drawbacks of the technology, I would like to just explain how our approach to this is. So if you imagine a typical hub motor would be something that you've seen in an electric scooter or something else, which is somewhat of a rim and motor kind of joined together, and then there's a tire around it. So we take a different approach. We're automotive level, which means that we actually use the space. That's, if you imagine taking a look at your car's wheel, you see inside, you see a bearing, you see a brake disc, and then you see some space, and then there's your rim and tire. So what we can do is actually fit an electric motor in the space that's between the brake and the rim, and that's it. And we integrate our motors in a way that they can use existing vehicle bearings and existing vehicle braking systems. So you use the space that's already on the vehicle. It's very lightweight, very compact, highly performant, and you get a lot of benefits in terms of controllability and safety aspect, and et cetera, et cetera. And what this gives you is an option also to really make a modular platform, because you can have 2, you can have 4, you can even have 3 or 1, depending on how you control everything. You can have 6, you can have 8. They can be very unique and modular. You can make this on different models of platforms and use the same powertrain, and they fit with standard suspension parts, standard bearings, standard brakes. So there's also another important aspect is they work both directions. So both directions and without, and also in regeneration. So you don't have any gearing in between. It's completely direct drive. So there's no additional losses, no complex mechanics that need to be maintained, no moving parts that create unnecessary friction and possibility of failures. So there's just one moving part per wheel, which is the bearing itself. And I think that's a pretty incredible thing to enable to the market. Now, you've seen a lot of these new concepts, how they're built, autonomous last mile delivery, all these things. And they all built on a premise that they need very specific requirements in terms of, usually it's, you want to have as much space as possible, the lowest floor as possible, and you want to build, let's say, a one platform that you can size to different types of vehicles, because that in the end saves you money. So there's a lot of different benefits that we can cover, and I propose that we go a little bit into those. Now, one of the important things to understand is, just to give you a frame of reference, is all the things that can happen for someone that's starting off with a new vehicle design. So essentially, you can have a lot faster time to market in all phases of vehicle development, and you can have a lot bigger economies of scale because of the modularity. You can also enable some designs which are not possible in any other way, or they might be too complex or too costly, because packaging the electric car together can be a challenge if you have to do everything on the axle, for example. And then as you move the torque generation out to each individual wheel, you're making the car actually a software-defined car. And that is where the real freedom comes from, going into the next 10 or 20 years. And it's completely autonomous already. You can use the motors as sensors for the autonomous system, and you can actually change the driving behavior of a vehicle's motion control, safety, braking control. Everything is a lot more responsive, and it happens really fast, and it can be, let's say, under your largest influence. How we try to help the market is, obviously we're a tier 1 supplier and a system supplier, but at this stage, we're basically an enabling technology. So what we want is to provide our stuff, make sure that it works, and give it to others so that they can do different things on top. Exactly like Trigo, you want people to be able to innovate on your technology, because you have a technology that enables you to do something much better, much bigger, much greater, that has a much better impact on the planet. Obviously, we do have activities that we do on the side that help push the technology further, but as in the essence, we have the whole system that we try to give to people so that they can focus on what they need to focus on. And that's definitely not developing motors and developing electronics or software, but it's developing the user experience, it's developing the usability and the value of a certain vehicle. And I think that's a really important thing to do. A little bit about the history. We've been doing this a long time, and we've developed a lot of things in the past 15 years. And trying a lot of things brings you very close to where you need to be in terms of finding the right solution. So I can honestly say that we wouldn't trade this experience for anything anymore. And before I go into all the details of the benefits, just a quick introduction. So that's one of the most that's the most powerful in-wheel motor in the world at the moment, and you can see that it can generate 110 kilowatts per wheel, 1,500 Newton meters, and the total added weight to the wheel is only 32 kilos. It fits into a 19-inch rim. We do have smaller motors. We have 3 sizes that we offer to the market for prototyping, but then we do a lot of custom development for specific vehicles that have very specific requirements. Let me just skip this. And this is one of the 2 things. So how do we join let's say, the benefits and the drawbacks of in-wheel technology? So there are 2 main drawbacks, 2 main challenges that people apply. And one is, if you have in-wheel motors, you're going to need to have more power electronics and more motors than if you have a single e-axle. And the logic goes, on a component level, it's going to cost more. Well, it actually means that using in-wheel motors, you can actually make the vehicle cheaper. But you have to take a look at the whole vehicle, how it's designed, and what the technology enables you to do, where you can save money. So if you imagine, if there's one drawback that's cost, I can tell you for sure, and other OEMs have recognized this, that using in-wheel motors is probably going to allow you to do the vehicle in a cheaper way. And that's obviously one thing that's important to the market, both to the users and to the producers. They need to make their margins to invest in R&D, and people don't need to pay that much for the vehicles in the end. And then if you continue, so I can show you a little bit about where this comes from. In the most cases, so there are 3 main benefits that feed into the cost saving, and this is the way you design the vehicle with in-wheel motors. It allows you to reduce a lot of mass, which in turn also increases the efficiency, because mass is one of the single most biggest contributors to energy efficiency. And by doing that, you can save money on the battery, and you can save money on the material, and you can make the car smaller. And then it goes into this optimization cycle where you can really do a lot of things in a better way. And if you can imagine, we can save easily 100 to 200 kilos just on the powertrain level, and then much more on the vehicle level. And if you go forward, the volume of cars, you can do a lot there as well. And even if you want to just have a bigger trunk space to compete on the market, I mean, that's better, but there are much more beneficial uses for the technology, such as, you can have easier handicapped access. You can have more storage for goods that allow you to, deliver more efficiently in last mile delivery or first mile delivery. You can do a lot more space, so you can stand inside the vehicle instead of just, hunching down. And there's all these sorts of very application specific uses where this comes in handy. As an interesting fact, you could actually have the size of a Golf, interior size of a Golf in a car that is externally the size of a Volkswagen Up, which is a very interesting case. And then, of course, you go into the efficiency. So on the one side, you have the efficiency benefits from the mass reductions and from the volume reductions. But then again, you also don't have any other friction elements in the system. I mean, these are relatively small changes, but on a vehicle level, the efficiencies can be way, way bigger, even up to 20%, which then in turn gives you a much better, let's say, use of energy. I mean, electricity is cheap, but it would allow you to give a better, bigger, longer range. But even so, objectively for the planet, you want to reduce the consumption of energy. And I think we can save a lot of CO2, and we're talking about millions of tons, if we make more rational vehicles, which are still more exciting than today's vehicles, better looking than today's vehicles, and they can be software upgraded for how they drive. And I think this is a lot of benefits for the market going into the future. This is just an overview of this. You know, obviously for different types of vehicles, you have a little bit of a different math. But to give you an idea, a little bit outside of the cost, you can really do a lot in terms of torque vectoring and safety systems, because if you imagine your ABS is very slow in terms of mechanics, your ESP is very slow in terms of mechanics. The character of the car, whether or not it's fun to drive, whether it's economical, whether it's aggressive, whether it helps you in critical situations, how much time you have to react, the difference between hitting a wall and not hitting a wall, if you're braking on ice, etc. So all of these things are coming together with the notion of the same distributed drive modularity. And of course, then you have the special cases where you need to have increased steering, or if you need to have, you know, a very simplified production line, or if you have to have very quick responsiveness of torques per wheels. All of that is more focused on usually autonomous vehicles like people movers and goods movers. But all of that is, of course, an added value that in-wheel architecture enables. And there are some other levels on the how you produce the vehicle, but that's something that we don't need to get into, and I think you can cover this in questions later if you have any specific questions. Now, I think the second biggest objection is unsprung mass, and I agree with my colleague from Trigo that said that in their vehicle that's probably going to be a big influence. It's a very lightweight car. It's a small car. It has 4 motors. And those motors are quite heavy. So I can believe them that they had some issues with this, but I can also tell you that on a, let's say on a car level, where we're talking about, you know, performance of, you know, 110 or even 200 kilowatts in 30 kilos of unsprung mass, on a vehicle that weighs 2 tons or 1.5 tons, these effects are not only negligible, but they can be completely tuned out by using the right suspension settings. And I think this has been proven multiple times. And I can tell you these were directors of chassis design and vehicle dynamics from Byton, from Lotus Engineering, from Continental. So all of them show that this can be done. And I can tell you from experience, we've done it on our cars. And let's just say that the vehicles are more comfortable than the originals that we bought, but at the same time, they're very, very close to Mercedes, which, you know, is based on comfort. So from that point of view, I would like to say that I think it's one of those myths that the Mythbusters should take a look at, really. It would help, and I think we're going to be planning something like this in the future. And going forward, just to kind of give you the idea about how things are going to evolve, is in-wheel motors are essentially a platform decision, which means that you have a distributed drive platform that you can really have modularity of a 2-wheel drive, 4-wheel drive, front-wheel drive, rear-wheel drive, how it controls. You can even have it modifiable later on in life, not only in production. And it's a software-defined experience. And the biggest value is then in the software applications that you apply on it. And I think that this is going to be the game changer from a vehicle standpoint. And just to continue a little bit on, this is a little bit more of a, let's say, what Elafe does, not so much about the technology, is we focus on everything from the design of a specific motor to power electronics to software, and also developing the mass production processes for producing both the motors and the software and everything else. We do a lot of tests around the globe together with customers ourselves, just to really validate the technology, that it can handle all the potholes and all the curbs that it hits and everything. It can drive underwater, it can drive in minus 40 or plus 85 degrees, etc., etc. And all of these things come together in the end when you launch a customer vehicle. So that's it from my side. I hope I wasn't too long. It's a very interesting topic, and it's a very broad topic. And I think that whoever has any questions, feel free, please reach out to me on this email. I'll be happy to share, let's say, some specifics with you. And now I'm opening up if there's any questions. Thank you very much.
Thank you very much, Luca. Indeed, the presentation was very interesting, and we got a very good idea of all the activities and products of Elafe. Are there any questions from the audience? Yes, I can see Mr. Seremet has a question. So just a moment to unmute you. You can unmute your... Okay.
Hello. Thank you for the very interesting presentation. As far as I know, at the moment, there is no automotive producer that has announced a car with a hub motor or hub motors. Why do you think is that? Is there the reluctance of change?
No. Actually, they have announced it. So we are going into mass production next year with at least 2 or 3 OEMs. Now, these are admittedly startups, which means that they might have billion-dollar budgets, but they're still startups. And we work with the majority of the OEMs around Europe and everywhere around the globe. This is a topic that they've investigated a long time. So if you imagine, GM has unveiled vehicles with in-wheel motors 20 years ago. Toyota, Nissan, all these guys have unveiled concepts, but it takes time for these. I'm gonna say they're not dinosaurs. They're very, very good companies, but they have a lot of processes because they're so big, and it takes time. And market change, like in physics, every change has a pushback. It's a law of conservation, and I think now is the actual right time. If you imagine, 20 years ago, there was no electric mobility at all, not even basic. There were no batteries, there were no other stuff. So people need to focus first in developing this kind of systems before they can imagine how an electric vehicle drivetrain could actually be optimized. And you saw this from the evolutionary stage. You take a look at how the electric vehicle began. So at first it was, an electric motor mounted to the central gearbox. And then you started to do 1 motor per axle. And now you have 3 motors per vehicle already. And in some cases, even 4 motors per vehicle, like you're looking at Rivian, you're looking at the Rimats, where they still use gearboxes because they have incredible torque requirements. But when it comes to the majority of vehicles on the road, I think that it's just a next step in the evolution. That's it. And it's coming. People are investing in it, and people are requesting it.
Thank you.
Yeah, no problem.
Okay, thank you. Any other questions? Okay, thank you again. Allow me just to notice something. Elafe was one of the first companies in the area of electric mobility that I had noticed a few years ago. And I have to admit to Luca that you are always part of my lectures for electric mobility because you have a lot of information, useful information in your website. So thank you again.
Yeah, it was my pleasure. Thank you all for listening, and feel free to reach out to me. I will be sending the slides to Professor Kosmanis, and he can then distribute to the participants.
Thank you very much. So the next presenter will bring us to the area of autonomous vehicles. It is Mrs. Urska Skrto from the company Subcorda Services GmbH from Germany. Urska, is your you can share your screen.
Yes, I'm sharing my screen and I think I'm unmuted, correct? Can you hear me?
Yes, I can hear you. Okay. We can all hear you, I believe, but we cannot see your screen.